I'll
Okay.
send it to you, okay?
Okay.
Or maybe I'll upload it on YouTube and then send you the link or something like that.
Okay.
That might work out better for me, actually.
Okay.
All right, so again, we're doing linear equations, yeah? So this was the question. So she pays 19 bucks a month, and then for every extra megabyte, it's $1.15.
You're not screen sharing anymore.
Boom, boom. What about now?
Yeah, that's good.
All right, so if she has 60 bucks in total, yeah?
Mm-hmm.
How many megabytes can she buy?
Y equals 60.
Y equals 60, yeah? So this is 60 like that?
I think so.
Yeah, right? Because the Y is the dependent variable, right? Y is the dependent variable, which is a total cost. So we're going to put that as 60, and now we're going to solve this equation for X. So what do we do next?
Sorry, is Y always dependent?
Y is always dependent, that's right. X is always independent.
Okay.
So this is going to be 60 equals 19 plus 1.15x, yeah?
Yeah.
All right, what's next?
Did we divide both sides by 60? No.
Nope.
By 19?
Divide? No, you have to do the opposite operation, all right? You're trying to solve an equation, yeah?
Yeah.
So usually what works best is if you follow the order of the reverse bed mass, okay?
Okay.
Now notice 1.15 and x, they're being multiplied, yeah?
Mm-hmm.
And then 19 is being added to this.
Yeah.
So what you want to do is you want to get rid of the 19 first.
Mhm.
So what do we do on both sides?
Mm.
The goal is to isolate this term, okay?
Yeah.
So we want to get rid of this 19 plus. Currently, it's being added to this term, yeah?
So 19 negative if we bring
So
on
yeah, exactly. We subtract 19 from both sides, okay?
Okay.
Now this goes away with this, and 60 minus 19 is 41.
Mm-hmm.
That is equals to 1.15x. What's next?
X equals 41 divided by 1.15.
Yeah, exactly. So 41 divided by 1.15, is that a nice number? No, it's not. It's like 35.65. So that's the answer, okay? 35.65 megabytes per month.
Okay.
Which is not that much, actually. 35, that's like, what, 5 pictures?
Mm-hmm.
That makes sense?
Yeah.
All right, let's do the next one. Solve the equation this. Okay, so there are a bunch of ways to do this, right? The easiest will always be the algebraic approach, and it's gonna be the most accurate. Again,
But the bed math backwards thingy?
yeah, the bed mass backwards thing. So what do we do first here? Do we get rid of the 3.5, 20, or 2.5?
2.5. So you subtract 2.5
Yeah,
from each side.
yeah, exactly. So minus 2.5 minus 2.5. 20 minus 2.5 is 17.5, yeah? What's
Yeah.
next?
And then we do x equals 17.5 divided by 2.5.
Yeah, and x would be 5.
Okay. Yeah.
Cool?
Mm-hmm.
Now here's a harder way of doing this problem. I'm gonna show it to you anyways, because sometimes they'll ask you to do this graphically, okay?
Mm-hmm.
So here, our origin is 0, 0. Right there is our origin. How do we sketch that equation? 3.5x plus 2.5. We're just interested in the left hand side of the equation. So we just want to sketch y equals 3.5x plus 2.5.
Maybe. Well, x would be to the right 3.5.
Okay, no. So here's what you do. Okay, I know what you're trying to do. You're trying to use the slope and the y-intercept to sketch this, right? So
Mhm.
to do that, you first start on the y-intercept, which is 2.5. There's our first point. Yeah.
Mhm.
The
But it's
slope is, yes, the slope is positive 3.5. So you want to go 3 units up from there. Okay.
Mhm.
So what is 2.5 plus 3?
5.5.
5.5. Yeah.
Mhm.
And then you want to go 1 unit to the right. You see?
Why 1 unit?
Because slope is rise over run. Yeah.
Mhm.
So that is equals to 3.5 over 1. There's an invisible 1 here. So the rise is 3.5. That's why we went 3.5 up.
Oh,
And then
okay.
run is 1. So we went
So
1.
that equation is y is
Yeah.
for y
Yeah.
because it's y equals.
Yeah.
Okay.
Okay. So there
Yeah.
we have our 2 points. And for a linear equation, you just need 2 points. You do not have to do it this way. This is the best way to do it. There's another way to do this where you just plug in numbers. You see? When
Mhm.
x is 1, y would be 3.5 times 1 plus 2.5, which is 6. Yeah. There you
Mhm.
have your first point. And then if I want whole numbers here, I can pick when x is 3, 3.5 times 3 plus 2.5, 13. There you go. And I picked 3 here because if I pick 2, I will get 7 plus 2.5, which is not a whole number. But you see these points are going to be the same.
Mm. Okay.
Okay. So start from 2.5. Okay. Go
Mhm.
3.5 up. Actually, I should have gone to 2.5 plus 3.5 is 6, not 5.5. There we go. This is using the slope and the intercept. And now if you notice, 1, 6 is using the plug and play method. We got the same point, and then you'll see that this point also lands on this curve. So I'm just going to join them and extend them. This part is not going to be very like supremely precise, but it's good enough because my line is too thick. But that works out.
Okay, wait. So you have a 2.5 there
Mhm.
just because
This is the
if
y-intercept, right?
is it if x is 0? Is that what you're doing?
Yeah, exactly. Yeah.
Okay.
The y-intercept, the b value here will always be when x is 0.
Okay.
Okay, and then 10, 11, 12, 13, and that is at 1, 2, 3. That's good enough, yeah. That's what we have here. But it should have been right on the line. It's just that I don't have the dots.
Mhm.
That's fine. So how do we solve this question? You see, that is equals to 20, right?
Yeah.
Where's y equals 20? Right there.
Yeah.
Yeah. And now we're just gonna draw a horizontal line and check out what the x value is.
Oh, okay.
So from that point onwards, the x value is 3, 4, 5. There we go. X is 5. And that's what we had before as well.
Yeah.
Okay, and this is doing it graphically. Not very efficient,
Yeah.
but you have to know how to do it.
Okay.
The best way is definitely doing it algebraically. It's like 2 steps.
Mhm.
But sometimes you don't have a choice. Like here they graphed it, that's fine.
Mhm.
Again, same thing here. We can do this either algebraically or we can do it graphically. But the graph here will be pretty small because it's just 3x plus 2 not equals 20. So let's do this first algebraically. It says determine the x-intercept, right? When you
Mhm.
think of an x-intercept, what is the y value at an x-intercept?
0.
The y value is 0, right? So we can simply put a 0 here and then solve this equation for x. What's the next step?
Minus 2 on each side.
Yeah. So 0 minus 2 is minus 2. Yeah. And what's next?
X equals -2 divided by 3.
And there we go. That's the answer, which is like, what is that? That is minus 0.6666. Okay.
Okay.
Now, if you want to do this algebraically, we are gonna draw this line first, 3x plus 2. And how do we do that? Start on the y-intercept, which is 2, yeah?
Yes.
1, 2. There's our first point. What's our second point? Look at the slope.
Mm, 3.
Yeah, so what would be our next point using the slope as 3? We started at 2, yeah? We started at 0, comma 2.
Mm-hmm.
What would be our next point? So we go 3 units up. Yeah, 1, 2.
Oh yeah, and then 5 would be
1
5.
unit, 1
5.
unit. 1 and 5, right? X and Y, X comma Y,
Yeah.
1 and 5. There you go. There's our second point, yeah?
Mhm.
And now we're gonna connect them, right?
Mhm.
And I'm gonna be trying, yeah, this is not gonna be very precise because you see this is -1, this is 0, right? And where's this? Could be negative 0.6, 0.7. We don't know what that is, right? See, this method
Yeah.
is not very precise. There we go. That's a precise answer. But this is how you would do it.
Okay.
Here's a question that you might have to do in real life. So they charge for a cell phone plan on $9.95 a month, 50 minutes is free, and then 0.09 per minute after 50 minutes.
Um. Okay.
So let's say if it's 51 minutes, then the bill would be 9.95 plus 1 times 0.09. If it's 52 minutes, yeah, you get that.
Oh yeah.
So up until 50, it's just 9.95,
Okay,
yeah?
so then you're just adding 1
Yeah,
after.
yeah, exactly. So every additional minute after 50, you're gonna multiply it and add it.
Okay.
So let's use an equation to resemble this information.
Mm. Mm.
Look at the question. The answer is in the question, basically. Let's first establish what X and Y represent.
Okay, so 40 equals. Is 40 the Y?
Yeah. So Y is the cost, right? Per
Mhm.
month. And X is
The
what?
month?
Not,
The month.
not month.
The minutes?
The minutes, right? The additional minutes. Okay, there we go. See, it's in the question. Basically, the answer is always in the question.
Mhm.
You just have to be able to read it, yeah?
Mhm.
So what would be an equation?
Uh. mhm. Okay, so
So this
0,
cost is fixed, right?
0.9x
Yeah.
minus 50.
So X is the additional minute, yeah?
Yeah, and then minus 50 because 50 are free.
So you can do 50, yeah, that's right. X minus 50.
Yeah.
Okay. And
Uh,
then plus
plus
9.995.
2.95. Yeah.
Okay, if this is not in our mx plus b form that we like, yeah?
No.
So what does the x here represent? The x here doesn't, this is not wrong, by the way, this is fine too. But the x here does not represent additional minutes. The x here represents total minutes.
Yeah. Yeah. Because we're minusing 50.
Yeah, so if you want to do an additional minutes, like a little bit less math, yeah? You just put an x here.
Oh, okay.
And this is easier to work with, yeah?
But then you're not subtracting a 50.
And then we'll add 50 at the end, whatever we get as x, we'll add in 50 and that'll be the total minutes.
Okay.
Okay, let's do it both ways actually, because just in case, right? We should get the same, we'll get the same answer. All right, so we have 40 bucks to spend, right? How do we solve this equation?
We have to subtract 9.95 from 40 and then 9.95 from 9.95.
So we have 0.09x. Okay, this is what we have so far. 40 minus 9.95 mental maths, that's 30.05 equals 0.09x. Now
Yeah.
what?
And then x equals 30.05 divided by 0.09.
Yeah. So what do we get as the answer? Again, it's not a nice number. It's got 333.89 minutes.
Okay.
So this is the additional minute, yeah?
Mm-hmm.
Because that's what the x here represents. Here, x is total minutes. And then we'll just add 50 to this to get the total minutes, which is 383.89 minutes. Okay?
Okay, so you're just solving for the total minutes.
Yeah,
Yeah, that's what the question's asking.
yeah.
Okay.
So this is the total minutes. This is the additional minutes. We do the same thing here. It'll be the same thing here. So it'll be 40 minus 9.95 divided by 0.09 plus 50. That's what x would be.
Okay, so yeah. Mm-hmm.
So this is basically 333.89, and then we're just adding 50. So they're both fine, okay?
Okay.
They rounded it up. That's fine too, I guess. It says about. Cool. Pretty simple, right?
Yeah.
It's not that bad. Linear equations. I mean, let's do this rocket question. Seems interesting. Right. So a rocket is launched from a hill, 700 meters high, and its altitude is going up by 35 meters every 2 seconds. Create the linear relation that models the rocket's upward path. What does that mean?
Do they want an equation showing its path?
Yeah. So there'll be an equation here. So again, we're interested in x and y.
Y equals 700, I think.
Y is not going to be constant because the height is going up every 2 seconds, yeah?
Oh, but isn't the hill 700 meters high?
Yeah, it is. The y-intercept would be 700. Right? We're trying to establish an equation in terms of y and x.
Okay. Would it be?
So first of all, what does y represent? It's the height of the rocket, yeah?
Yes. Okay. 35 then meters.
No.
And then
What does x represent? Wait, let's establish what y and x is.
the time.
Yeah, exactly. Time in seconds, right?
Mm-hmm.
Time in seconds. So y is equals to, okay, mx plus b, yeah? We know the y-intercept is 700. When time is 0, the height is 700, yeah?
Mm-hmm.
What is the slope?
35 over 2.
Yeah, good, perfect. There we go. 17.5x. There, that's our relation.
What is x? Oh, x is time.
Time in seconds, yeah. And y is height in meters.
Okay.
So far, so good?
Yeah.
All right. Graph the linear relation. That's not going to be fun. But how would you graph this?
The y-intercept is 700. So would the first one be 700?
Yeah, there's our first point, yeah.
And then it would be 17.5 plus 700.
Yeah, which is 17.5. And then we go to the right by 1. Yeah, there we go. It's simple. Again, this is not going to be very precise because 717.5 could be anywhere here, right?
Mm-hmm.
So I'm just going to put it a little bit around 725. Yeah. And there we go. That's our point. Okay.
For a linear equation, like when they want you to graph it, will the second dot always be 1 to the right?
No, not necessarily. Like here, it could have been, we could have done 35 over 2 instead of doing 17, which is what it is. Yeah.
Yeah.
We could have gone 35 up and 2 to the right.
Mm-hmm.
It would be the same. It would be the point right here. You see, it's going to connect this line. It'll be on this line. but it'll be a further out.
Okay. Oh, because it's all over 2.
Yeah.
Okay.
So we would go 35 up and 2 to the right if we use this. But we just, yeah.
Wouldn't it have to be plus 700?
Yeah, from 700 though. You start at 700 and then you go 35 up and then you go 2 to the right.
Okay.
Okay, that's if you're using this. But we just divided it and we would use 17.5. And our sketch here, you see t represents our x represents time, yeah, in seconds.
Yeah.
Time cannot be negative, so we're not interested in any of these quadrants. Our graph will strictly be here. So you don't
Yeah.
have to sketch anything else, right? Just that is fine.
Yeah.
Because time will never be below 0. Height can be, I guess, if it's going below sea level or whatever, but not time. Time will never be negative.
Yeah.
And that's the answer to part B. Write an equation that you would use to solve blah, blah, blah. When the time is 50 and 100 seconds, what is the height?
Okay, so they want individually like 50 seconds and 100 seconds. So
Yeah.
x will 50 then 100.
Perfect. So 17.5 times 50, yeah,
Mhm.
plus 700. So the answer to 50 is 15. This is a plug and chug, right? This is simple.
Yeah.
This is 150, and when it's 100, 17.5 times 100 plus 700. So 17.5 times 100 plus 700 gives us 2450.
Okay.
And if we did this by the graph, I mean, we don't have space for this. Yeah, I did one each, right?
Mhm.
There's no way to go 50.
Yeah. Yeah.
So that's not gonna work out on this graph, but you know how to make it if you need to. Just go by 10 each time here. You
Yeah.
see? 10, 20, and
Then
you'll,
it wouldn't be as precise if you need
yeah,
that.
exactly, it won't be. That's why it says estimate. And with the graph, it'll never be like, what is the precise answer? It'll always be like estimate or what about.
Mhm.
Now, part D, it says, what's the time when the height is 1,000?
So y equals 1,000.
Yeah, exactly. You're gonna replace y with 1,000. Again, how do you solve this linear equation? Super simple, 2 steps.
700 minus 1,000, 700 minus 700. And then 1,000 divided by 17.5.
Yeah, there we go. That's our x.
Mhm.
So 1,000 minus 700 is 300. Yeah, 300 divided by 17.5. And that's about 17.14 seconds. Okay.
Okay. Yeah.
And actually, we may be able to somewhat see that. 800, 900, 1,000, right? That's our 1,000. So where will our curve hit this? So we wanted to hit, the answer is 17, we know for sure, right?
Yeah.
Okay, this is 10, 11, 12. Actually, I can just do this. Yeah, it's not precise at all, but it gives you an idea. 12, 13, 14. It's a little bit higher than 14 on this sketchy curve.
Mm-hmm.
But the precise answer is always algebraically, and that's 17.14.
Okay.
Now they've already given us a graph. How do we work backwards? They've given us this graph. How do we find what the equation is?
Oh, okay. So the x would have, no, it'd have to be over 5. No, I don't know how to do that.
All right, you need to see what the y-intercept is, right? What does it say? Earnings against hours work. If you don't work any hours, you have no earnings, right? That makes sense. And also see the y-intercept is 0.
Yeah.
Y equals mx plus b. So from the graph, b is 0. Also by intuition, if you don't work, you don't get paid. So b is 0. So we already have y equals mx as our equation, right?
Mhm.
This is a direct variation. because it passes through the origin. Now the question is, what is m? And we know m is the slope, which is rise over run. Yeah?
Yes.
So we're going to pick two nice points. What do I mean by nice? See this one right here. This is a nice point, yeah. Or is it? What's in the middle of 60 and 65?
62.5.
Yeah, so 60. Oh, that's as nice as it can. It's a precise number, right? It's better than like this one. We don't know what that is. Or like this one here, we don't know what that is. So this is one nice point. Now we're looking for another nice point. I guess we can use the origin.
25 and 200.
Yeah, there we go. We can also use that. So I guess we can just use this and 0, 0. That'll be even easier. Okay. So we can either find the rise and the run here, or we can find the rise and the run here. I'm going to pick 0, 0 because it's easy math. Yeah. So the rise, what will be the rise from 0 to 200?
Oh, to 100?
Yeah, and what will be the run?
Oh, 200.
125, right?
Yeah, 25.
So it's 8. There we go. Slope is 8. So our equation is y equals 8x. Yeah?
Yeah.
Where y is the total amount earned. Yeah?
Mm-hmm.
And x is the number of hours worked. So her wage is only $8 an hour.
Oh, okay.
That makes sense?
Yes.
Part B, write the equation you would use to solve for 500 bucks. So if y is the earnings, right? If that's 500 equals 8x, x is going to be 500 over 8.
Yeah.
So 500 divided by 8, that is 62.5. And that's actually the point we had here.
Oh, yeah. Oh.
So that's the answer to that question, 62.5 hours for $500, which is not much. That's illegal. I guess this book is old. Write the equation you'd use to solve to determine her earnings for 40 hours worked. All right, let's do that. Again, y equals 8x. We want the earnings, we want y, and we're given the hours worked 40, right?
Yeah.
So simply plug and chug. 40 times 8, $320.
Okay.
And we can also see that graphically, right? Where's 40? Actually, we can. It's not precise, but I guess we could.
Yeah.
You see, it's not very precise. It's below 350, so that's precisely 320.
Okay.
How are the equations in part B and C similar? How are they different?
Well, they're different because one, in order to solve, you need to multiply, and the other you need to divide.
Mhm.
And they're similar in the way that you're plugging in numbers to the variable.
Yeah. Estimate the solution. Well, we already did that, right? This one's precise, but the other one is not very precise.
Yeah.
Part F, solve the equations. We already solved it. So we just needed to write the equations for B and C.
Okay.
Very simple, yeah. Not a whole lot going on. It does get difficult though. You know what? I'm gonna give you a question. What would be a good question? 3 over 5x plus 2 over 3 equals 9 over 8. Solve for x.
Okay. So first you'd have to subtract 2 over 3 from 9 over 8. Could you just make them into decimals first? Wouldn't that be easier?
You can make them in decimal. They're not going to be nice decimals. They're going to be irrational numbers.
Okay, then maybe not. So you'd have to subtract 2 over 3 from 9 over 8.
Yeah.
And they can be common denominator. Okay, so I'd have to find a common denominator.
Yes.
24.
So we're subtracting this with this, yeah?
Mm-hmm.
It is 24, right? 16 does not go into 3. So what's next?
Okay, so you have to put them both to 24. So 24 over 24. And then 8 times 3.
Mm-hmm.
Yes, then 9 times 3. So 27. And then, yeah, And then you just subtract those.
I'll be your calculator. That's 11 over 24.
Okay.
Now what?
Now you have to divide 11 over 24 by 3 over 5.
All right, actually, that's perfect. Yeah. So x equals 11 over 24 divided by 3 over 5. If you use a calculator, it won't give you nice numbers.
Times 5 over 3.
Yeah, perfect. Right. So 11 over 24 times 5 over 3. So 55 over 72. There we go.
Yeah. Yeah. Could that be reduced? Or
No, it cannot be.
Okay.
How did I know that so quick? 55 is divisible by 5 and 11 only.
Yeah.
Right? And 72 is not divisible by either one of those. That's why.
Okay.
What about this?
3 over x equals 2.
Solve for x.
Okay. X equals 3 times 2.
No, 3 over 6 is not 2.
Right. Hmm. 1.5.
Yeah, the answer is actually, it is a 1.5. Yeah, but how did you get it?
I was trying to do it like mathematically, but then I just did it by what I saw. Like 2 times 1.5 equals 3. I did 2 times what equals 3.
So here's what you do, okay? Again, we're trying to solve for x, right? We're trying to solve for x. What do? We need to isolate x, okay?
Yeah.
What we do is this. We divide both sides by 3. Okay, 3 is in the top right now, right? The goal is to kill off the 3 on the top, right? So we can either, dividing is the same thing as multiplying by 1 over 3. Dividing by 3 is the same thing as multiplying by 1 over 3. Okay? So see, this cancels out with this. And then you have 2 over 3 on the other side, right? You have 1 over x equals 2 over 3. Okay, but we're not done yet. We're not trying to solve for 1 over x. We're trying to solve for x. What do we do now? We flip it. We want x in the numerator, yeah?
Mm-hmm.
So we flip both sides. And there you go. 3 over 2 is 1.5.
Okay.
Alternatively, here's the smart way of doing this. Not the smart, but the shortcut. If you see a question like this, when the unknown is in the denominator, you can literally swap places with this. 3 over 2 equals x.
Okay.
Like 9 over x equals 3. We know the answer is 3, or you can just swap places with it.
Okay.
Okay.
Mm-hmm.
Let's move on. More equations, yeah? You good with this unit?
Yes.
All right. What's going on here? So she delivers paper. She earned this much in total. And her costs were $8 for gas and her earnings were 72 for paper. Determine the amount of paper waste Michelle delivered on her trip.
Uh, 8, 23 equals 8g plus 72.5p.
So this is her net earnings, right? So we can't have two variables, by the way. That's a good thing. Like when you're trying to solve an equation, yeah, if you have two variables, like if you have y equals 3x plus 2, you can't solve this. This is not an this has an infinite number of solutions because that's just a straight line. So in an equation, ideally, when you're trying to solve it, you only want to have one variable. But what is going on here? See, this is her net earnings, yeah? So what does net mean? Net means whatever she earned, yeah? You subtract that with what it cost her, right? Here she had to pay for gas.
Oh,
So this is the net earnings, okay?
okay.
So what did she earn? She earned
72 times paper.
yes, times x. 72.50 times x, where x represents the number of tons. Okay.
Yeah.
And she only did one trip, right? First trip, $8 a trip, so minus 8 equals net earnings 23.90.
Okay. Do they want us to solve that?
Yeah, we're trying to solve for x.
Okay. So minus 8 from 23.9 and
Not minus 8.
oh, plus 8.
Yeah, plus 8. Right?
Plus 8.
And then you have 72.50x equals that. And then we add them up. What is that? Plus 10 minus 2, 31.90.
And then you divide 31.90 from 72.5.
Yeah, so 0.44 tons is the answer to this.
Okay.
Okay. Again, very simple, right? Just a linear equation. The hard part is, again, you wanna make the equation. Yeah, that's always the hardest part. They did something. I mean, they got the same answer, but I don't know what they did. I mean, if you have this, right? If you have this, then you should be able to solve it.
Yeah.
Add 8, divide by 70. It's a two-step answer. Here's another equation. What about this? We're trying to solve for x.
-5 would be?
-5? No, that's not wrong. That's wrong. That will give you -6 as the answer. But how do we solve this for x?
You would take away 4 from 14.
Actually, you're right. You said -5. Yeah, my bad. Yeah, that's right. I thought you said 5. Yeah, so 10 over -2. That's easy. -5 was right. What did they do? Why are they making it look so hard? They're doing the same thing we are. They're just explaining all the steps. Okay, here we are. We have a fraction.
Would you still deal with the 13 first?
Yeah.
So you would have to take away 13 from 7.
So 7 minus 13? Like that?
No, plus.
Plus, right? Exactly. So you have 20 equals W over 3. Now we need to get rid of the 3 in the denominator.
Didn't we have to multiply by 1 over 3?
No, that's when that was the unknown was in the denominator then. Here W is in the numerator, so we don't do 1 over 3. You just do the opposite operation, yeah? See, it's being divided by 3 right now. You just multiply it by 3 on both sides because these cancel out.
So when it's on the numerator, you multiply.
Yeah. If you have 3 over W, yeah, then you multiply by 1 over 3 because you want them to cancel out.
Okay.
So you get W equals 60 for this one.
Okay.
photographer charges a sitting fee of $100.
Mhm.
So what does this mean? This is they earn $100 no matter what. Okay.
Okay. Yeah.
The first 4 prints are free. So this is like the 50 question that we had, the 50 minutes
Okay.
question. Each additional print costs $5.25. How many prints can you buy with $257.50?
So 257.50 would be Y.
Yeah, good. So what does the Y actually represent? It represents the total cost, right? In dollars. And what does X represent?
Additional print
Yeah,
cost.
exactly. So what's the equation here?
5.25 X plus 100.
Yeah, but X is not additional print cost. What is X? This equation's fine. But what does X represent? X is additional prints.
Oh,
Only.
yeah.
Okay, it's just additional prints. So we're trying to solve this equation for X, right? And remember to add the 4 at the end.
Yeah.
Okay, if you don't want to add the 4, then you have to do 4 minus X here.
Okay.
So again, subtract 100 from both
Yeah.
sides, yeah? From here, it's simple. Like,
And then divide that by 5.25.
these equations are not that bad. It just gets a little bit messy when you have like fractions, right? When you have to take the common denominator.
Yeah.
So X is 30, there we go. You can buy 30 additional prints, but in total, you can buy 34 prints.
Yeah.
Easy enough?
Yeah.
Let's do this submarine question. I like submarines, they're cool.
Yeah.
So it's submerged at a depth of 600 meters. It rises at a rate of 4 meters per second. So
Okay.
we're gonna write an equation between the depth and the number of seconds.
So M is the rate in the equation.
Yeah.
Then plus 600.
So wait, 4 plus 600, what's going on here? First, let's establish what y and x is. It's already given here. What is y and x?
Depth and seconds.
Yeah, exactly. Y is the depth, x is seconds, right?
Yeah.
So we know 600 is the initial value, yeah? When time is 0, the depth is 600, so that is our y-intercept.
Yeah.
Okay, what is our slope?
4 meters per second.
Yes, our slope, rate is always the slope, yeah? So it's just 4. But there's something wrong with this equation. All the numbers are right, but something's off. Because if you rise 1 second, you're gonna go 604, right? But you should have been at 596. You're going up. You're not sinking. You're going up to the surface. So what is wrong with this equation? How can we fix it?
Minus 600.
Minus 4x.
Oh. Okay.
And this will give you the depth, right? Does minus 600 work? I guess it does work in a sense. You get minus 596 as the depth. But this one will give you the whole number.
Okay.
Okay?
Yeah.
So part B. What time will it reach a depth of 486 meters?
So 486 equals Y.
Yeah, exactly. Now how do we solve this equation for x?
486 minus 600.
Yeah,
And then divided by -4.
yeah, perfect. Not plus 4. A lot of people do plus 4 there. Don't do that. And if you're plugging this, why don't you plug this in the calculator? Let's see what you get.
Okay. 28.5.
Yeah. So after 28.5 seconds, the depth would be 486, yeah?
Yeah.
Part C, list the inverse operation you need to use to isolate the variable. We already did it, right? The inverse operation is subtract 600, divide by -4. Okay?
Yeah.
It says verify the solution. We already did C and D basically here. To verify, you just plug this as X in there.
Okay.
Do you get 486? You should.
Okay. Okay. Negative. Yeah, I get 486.
That's how you can verify if you got it right or not. Let's do a couple of these. Yes, we can just do one. This one. How do we solve for W? Again, the reverse bed mass works.
So -3.
No. But why not? Because look at that
Brackets.
bracket, right? So you want to leave that for the end.
So you do the division first?
Yeah, yeah. So what do you do on both sides?
Multiply by 3.
Not 3, no, not 3. What's being divided? You always do the opposite, right? This being divided by 4, you multiply by 4. Okay?
Oh, you always multiply by the
Yeah,
denominator?
yeah.
Okay.
I mean, this being divided, you multiply. If it was being multiplied, you divide. You do the opposite thing.
Yeah,
Okay?
but it's always by the
Yeah.
denominator.
Yeah.
Okay.
So this is gone here. So you get W plus 3 equals 8. From here, it's easy, right? You just subtract 3. There's no more brackets.
Mhm.
So W is 5. Okay?
Yeah.
What about this one? Bunch of negative signs.
Hmm. -1, -2 -1.
Yeah, good. So that's -3 equals -2c over 5.
Yeah. Now multiply by 5 on both sides.
Yes. So -15 equals -2c.
And then -15 divided by -2.
Yeah. So the answer is 15 over 2 because the two negatives, they cancel out.
Yeah, 7.5.
Yes. What about this one? Celsius, Fahrenheit. So this is the equation that, what does this equation do?
Oh, it's telling you the Celsius temperature
Yeah?
when you're given the Fahrenheit temperature.
Yes, yes. So first question here, 58 Fahrenheit, what's the Celsius, right? C equals 5 over 9 times 58 minus 32.
Yes.
And this is a calculator plug and play here.
Okay.
5 divided by 9 times 58 minus 32. So the answer is 14 and 4 over 9, which is 14.44 degrees Celsius.
Mhm.
It says, list the operations that you use to calculate the Celsius temperature. Well, we first subtracted, then multiplied, then divided. Yeah?
Okay.
Now here's a good question. List the inverse operation that you'd use to calculate F, to isolate F.
Oh, okay.
So we're trying to come up with an equation that gives us f, right, in terms of c, something like that.
Oh, okay.
So we're trying to isolate for this f here.
Equal plus 32? Or, no. Would it be f equals 9/5? And then c plus 32?
Is this in a bracket?
Yeah.
No, it's
No.
not. No, it's not, right? So what did we actually do? We first multiplied by 9, yeah?
Mhm.
Then we got this, and then we divided by 5, and then we added a 32, okay? So it's a 9c/5 plus 32.
Mhm.
That's what f is. And now we just want to plug 25 in there as c, and that'll give us the Fahrenheit equivalent. 9 times 25/5 plus 32, a little bit of mental math here. 5 goes into 25 5 times, yeah?
Yeah.
45 plus 32, 45 plus 30 is 75, so plus 2 more, 77.
Okay.
That makes sense?
Yeah.
Oh, what about this? Now this one has multiple x's. Actually, first of all, is this equation solvable? Can we get an answer for this, like x equals something or whatever?
No.
How many variables does it have?
2.
No, x is 1, yeah? It's just x and x. You can just move them and make them 1.
Oh, okay.
So this is solvable, right? How would we go about solving this?
Mm.
We want to put the like terms on the same sides. So you want to put the variables on one and then just the numbers on the other.
So 1/2x minus x/3.
Yeah. And what about on the other side?
-1/4? Or just, no, 1/4 is going on this side. Plus 1/6.
Yeah, there we go, right? Actually, we can take the common denominator between all of them if we wanted to, or we can just do between 2 and 3, 6 and 4. Here it's 12, yeah?
Yeah.
So times 3 times 3 times 2 times 2. Here it's 6, so times 2 times 2.
There could also be 12 though.
Yeah, they could also be 12. We could, I mean, if you make all the denominators common, you know what's gonna happen? They all cancel out. The denominator completely disappears. Here,
Isn't
check
that
this out.
funny?
Yeah, that is better. 6x/12 minus 4x/12, yeah?
Mhm.
Equals to 2/12 plus 3/12, right?
Yeah.
See, all of them have the same denominator. You can just completely eliminate them.
Yeah. And then 2x
Equal 5
and 5
x.
equals 2.
There we go. Easy, right?
Yeah.
So again, it's not that bad. And this is solvable. It's not solvable if there was a y here. You can
Okay.
only rearrange, but you can't like get like y equals to something or x equals to something.
Okay.
All right, then let's pick it up next time. So just a lot more word problems coming up.
Okay.
And I will upload this on YouTube. Okay?
Okay. Yeah. And they just send me the link.
Sure.
Well, to my mom.
Okay, I'll do that. I'll see you next week.
See you. Thank you.
Bye-bye.